All right, so here's example 1 done out for you, graphed. Now, this problem was a little difficult to graph because your vertex was way down here off the bottom of the graph. So it may have been a little difficult to graph for you. Okay, found my y-intercept, which was 0, -10. And then the key to this whole problem is finding the actual x-intercepts. Now, if you remember how to find an x-intercept, you set y equal to 0 and solve it. Now, this problem is very much easier to do by factoring. If you really consider, if you look at the way this problem is set up, graphing it's hard, again, because the vertex is off the graph and it's tough to figure out. It's difficult to figure out what these 2 points are by graphing. How do you know those 2 points are where they are by graphing? Well, you have to just test points and figure it out, do a little table. This problem is much easier to do by factoring. If you think about 2 numbers that add up to the middle and multiply to the end, remember this whole unit we did on factoring, chapter 7? The numbers are -5 and +2. Remember this when we factor? And then we want to know where it equals 0. So that means you just basically set each of these pieces equal to 0. So this piece, your x value is going to be +5, and this piece, your x value is going to be -2. Those are the 2 values that make this equal to 0. Those are your 2 x-intercepts. Those are called the zeros of the function. They're also called the roots of the function, or the solutions of the function. That's what we're after, those 2 values. Those are the solutions to this quadratic function, x equals 5 and x equals -2. So this, even though this example says to solve it by graphing, it was actually easier if you recognized to factor it than graph it. So that's what the rest of this file is all about, factoring. Okay? Now, we did a whole entire unit on factoring, chapter 7, and it was quite long, right? So you have to kind of recollect and recall all those factoring methods. Now, we won't do all the factoring methods, but there will be ones that you need that are more prevalent than others, especially this one. When you add to the middle and multiply to the end. X plus 5, x plus 7. 5 times 7 is 35. 5 plus 7 is 12. That is now factored. Remember number 4 down here? This is called a difference of squares. You put your 2 parentheses, you put an x here and here, you take the square root of x squared, which is x and x, you take the square root of 9, which is 3 and 3. 1 gets a minus, 1 gets a plus. Okay? I know I did these out of order, but number 2 and number 3, you need GCFs. GCF. Number 3, the GCF is 4x, and you're left with x minus 2. Okay? And that's it. That's all you could do with that one. And then number 2, the GCF is 2. And then you could refactor this piece here. 2 numbers that multiply to 16 and add up to -8 are -4 and -4. So this whole lesson, the rest of this file is all about factoring. So you need to brush up on that and review your factoring methods.